Okay, so I think we are recording. So this chapter, no, so the first chapter in the laboratory is about measurements, no. And in your lecture, magdi-discuss pa lang siguro yung iba sa inyo, no? But you have discussed the importance of chemistry, no? The problem with chemistry is that um, yung ating ini-investigate ay super liit, no? Tiny particles yung ini-investigate, no? Kasi imagine atoms yung focus natin sa chem, 'di ba? And you know atoms are very small, no? So they are in picometer size, no? Okay? So super liit 'yan and that cannot be seen by the naked eye. So you should ask, no, kahit papaano na paano kaya nila na measure ang ating atoms, no? Okay, so we will answer that for the entire midterm period, no? So yun yung goal ng midterm period na to identify how do we measure atoms, how do we identify their reactions, so on and so forth. No? But for now, focus lang tayo muna on this concept, measurement. Okay? So alamin natin what are the ways of measuring, how to convert one unit to another, and then by Thursday we will have reinforcement sessions. No, we will try to answer some worksheets. No, to really see if we understood the lesson well. So the chapter outline would be this one. I will try to reach until the end. No, para sa Thursday review lang tayo. Okay. So for now, mag-notes na lang muna kayo or just open this PowerPoint sa inyong notes, no? And mag-add na lang kayo ng words. Okay, so measurement, no? So in everyday life, we do measurement, no? And maraming ways to measure, no? Sometimes we use a measuring scale, no? For example, this tape measure. And then we have this weighing scale. Okay. So kumbaga, you place it around yourself or you put yourself onto it, no? And then it will measure your weight or your size, no? Sometimes naman we use thermometers, no? Para ma-check yung body temperature, no? So depending on the hotness, no, or the coldness of your body, there will be a measurement, no? There will be a temperature reading. Okay. Now, sometimes we use certain containers to actually get the volume of your measurement. So basically, ang measurement ginagawa natin sa buhay, no? Kahit hindi tayo chemistry students, no? Whether ikaw ay namimili sa palengke, ikaw ay ikaw ay nagtitimbang lang ng sarili, no? Just to see kung ikaw ay pumayat or bumigat, no? So, yan yung measurement na ginagawa natin in our daily life, no? So, yan. But in chemistry, no, we will try to understand, no, um, yung purpose ng measurement na and paano ba tayo nagme-measure, okay? So typically, when we measure things, now we represent it using this notation. Okay, so our measurements are reported, wherein we have a number, no, to display the magnitude, no, the extent of that measurement, followed by a unit, no. Okay, para may sense kung ano yung pinag-uusapan natin. Kunwari, you say 1 kilogram. So yung 1, ibig sabihin nun, edi isa. Kilogram, this tells us ano yung isa na yan. Okay, so it makes sense of the quantity. No? So the unit makes the quantity um, makes the quantity in context. Na sabihin natin in context. Okay, so ano meaning ko doon? Kunwari, 1. Ano ba yung 1 na yan? 1 Carabao ba yan? Or 1 person? Or 1 kilogram, no? So, sasabihin niya yung context, ano yung number 1 na yan, no? Okay, so that's how we report measurements, no? We have a number wherein we show here the extent, no? Or the magnitude of the quantity, or I mean of the unit. Okay? So ganun. Sinasabi niya kung ano yung number na yun. Okay? And maraming uri ng units, no? Okay? So mag-brief discussion lang ako dito about short history nila. So all throughout sa world natin, we have three distinct types of units of measurement, no? So start tayo with the English one, wherein this dates back to imperial times, no? Mga imperial period, no? Okay, another term for English is the imperial period, no? So ano ba meron dito sa imperial period, no? Dati kasi, no, bago mauso yung mga tape measure, bago mauso yung mga meter stick, no, ang ginagamit nila ay katawan ng tao. Okay? Kunwari, ako hari, no. Let's say, hari ako ng United Kingdom. Okay? So, lahat ng measurements ay nakabase sa katawan ko. Okay? So, for example, ano kaya meaning ng 1 feet, no? 1 foot, 1 feet. Ayan. Ayan. Ano kaya meaning niyan? Feet, ibig sabihin literal, paa yun. Literal na paa. Ang tanong, nino? Ng hari. Okay? So, ganun yung measurement dati. No? Yung body size ng tao, siya yung basis for all other measurements. So, kunwari, ang distance ko from here to my laptop is 1 foot. No? Ibig sabihin nun, yung paa ko, yun yung gagamitin kong pang measure ng distance. Okay? And then, with that, no, they can measure lengths, no? For example, 3,000 feet. So, it means literally 3,000 steps, no? Until you reach that point, no? So, ganun yung ganun yung basis ng English system, no? So, in the English system, basically, all measurements are based on body sizes, no? Okay? For example, from the tip of my finger up to dito sa balikat ko, this is isang yarda ata, 'di ba? If I'm not mistaken. So, yan. Kung sino yung hari that time, yung mga yarda, dun nakabase, no? Sa distance ng kanyang finger until dito sa balikat, no? Okay? Oh, in Tagalog, may mga ganyan din tayo, no, sa context ng Filipino culture. Meron tayong tinatawag na isang dipa. Ano meaning ng isang dipa? Mula dito sa tip ng finger mo until sa kabilang tip ng finger. Extend mo lang yung arm mo. Isang dipa tawag doon na. Tapos meron pa tayo sa Filipino, isang dangkal. Meaning nun, yung thumb finger mo and then yung pinky finger mo, extend mo yon. Isang dangkal yan. Okay? So, yun yung yun yung mga imperial methods of measurement. No? Okay? So, kunwari, isang ganito lang yung haba ng isang object, we call it isang dangkal. No? Pero pag dalawa yan, that's dalawang dangkal. Okay? So, ganun yung sistema ng measurement. No? So, may number tayo which represents how many of this yung isang object. Okay? So, ilang ganito yung isang object. Isang dangkal, dalawang dangkal, tatlong dangkal, no? So, yun yung context ng English system, no? So, basically, ang units na ginagamit sa imperial measurements ay body sizes. Okay? Mga katawan ng tao. Okay? Mostly hari, no? Okay. However, ang nangyari in the early 16th century, around 16th century, may nangyari. Siguro familiar tayo with this one, the French Revolution. Ano kaya nangyari sa French Revolution? Di nag-aklas yung mga French, no? What they did is they overthrew the empire, no? So, in-oust nila yung mga empire leaders and then they formed their republic. So, ano kinalaman yan dito sa lesson natin? Okay? So, from empire, no? From empires to republic. Ganito nangyari sa French, no? So, ano kinalaman yan sa lesson natin? Okay. Ganito kasi. Kunwari, hari ako ng UK. Okay. Tas kunwari, sino kaya pwede? Si Brian. Si Brian, siya yung hari ng German states, no? Si Inigo, siya yung ruler ng France, no? So, kaming tatlo, iba-iba yung size ng katawan namin, 'di ba? So, kunwari ako payat, 'no? Tas yung isa medyo malaki, 'no? Okay. So, ibig sabihin nun, kapag nag-trade kami, okay, kunwari may ano ako, 5 dangkal na kahoy. Pagdating sa ibang area, pagdating sa ibang kaharian, iba na yung size niya. 2 dangkal na lang kasi siguro malaki kamay niya, 'no? So, ang problema dun is kapag nagba-barter tayo or nagbi-business tayo, 'no? Empire to empire yung business, 'di ba? So, ibig sabihin nun, sa aking kaharian, lugi ako kapag nagbenta ako sa kanyang kaharian, 'di ba? Kasi magkaiba yung body sizes namin, magkaiba yung magiging presyo ng isang object, na same lang naman yung size, no? So, yun yung naging ano, isa sa mga nag-kickstart ng French Revolution, no? That empires are really unfair, no? Especially to traders, no? Sa mga ngalakal. So, ayun, together with other enlightenment during that time, no? Na-discover nila that that the monarchy, no, yung mga empires, it doesn't serve purpose for the peasants or for the normal citizens, no. So what they did is that they overthrew the empires, no, and eventually they reformed the systems of measurement para maging metric system. Okay? So ganun yung nangyari. Kasi mapapansin nyo, kapag English system, pasensya na, may nag-restart ng wifi. Anyway, sorry for that. We are still recording naman. Marami kasi kami sa bahay, kaya ganun. Anyway, asa na ako? Ayun, so sabi ko nga, no, pag hindi nyo ako narinig, sabihin nyo lang, ha. Okay, so nag-restart kasi yung wifi. Anyway, so yun na nga yung ganap, no. So ang nangyari is that since unfair ang trading sa mga normal na merchants, no, dahil iba-iba yung body size ng mga emperor that time, yung mga hari. So they overthrew the empires, no, and they formed the republic, and then together with it they introduced the metric system. Okay. So ano yung major difference kaya ng metric sa English? Sige. Brian, may question? Nawala yung PowerPoint. Sorry. Mukha ko lang pala nakalagay sa inyo. Sorry. Ayan. 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 Kita niyo na? Okay. So anyway, kita nyo na naman siguro. So yun na yung nangyari, no? Ano sa tingin nyo yung major difference, no, from metric to empire? Ano sa tingin nyo yung unang ginawa nila when it comes to measurement? They, any idea? Ano ba yung unfair during that time? Yung, body sizes. So pagdating sa metric system, they remove this thing, no? Tinanggal nila yung body factor sa measurements so that fair yung treatment, no? Fair yung measurements natin. Okay? So for example, yung isang tawag dito. Ay, nakalimutan ko yung tawag. O yung isang ganito ng isang object will be the same with the others na, no? Bakit? Kasi I introduced physical constants, no, sa metric system, physical constants, no. So basically, lahat ng measurement ko may basis na. Hindi na body ng tao, kundi physical objects, no, na pwede i-replicate. Isang example nun is the meter stick. No? So yung meter stick, dati pa talaga yan. No? Mga 16th century pa yan. No? Until now, ginagamit natin siya. Okay? So ibig sabihin, yung size ng stick na yon, that's 1 meter. No? And that can be replicated. No? So kuha ka lang ng kahoy, putulin mo at that size, then you can distribute it around the world. No? So yun yung kagandahan ng metric system, no. So they remove the body factor, no, sa pag-measure. So instead they have united na kapag isang metro, ganito dapat 'yan, okay? Pag isang litro, ganito dapat, no. So on so forth, no. So yan, tinanggal nila yung body factor, and then that helped launch the um, industrial period, no, yung mga panahon na lumakas talaga yung pagbebenta, no, sa iba't ibang mga syudad, no, until now, no. Yan, so basically products tayo ng French Revolution, no, yung ginagawa natin right now is product ng French Revolution. Okay, so yan, in the metric system also, they tried to push the decimal system. Okay. So based on the word itself, decimal, ibig sabihin, factors of 10 ang measurement, no? Factors of 10, 10,000, 100, no? 1,000. So doon naka-base na yung ating measurements. Okay? So for example, centimeter. Ibig sabihin nun, yung isang metro, hatiin mo sa 100 equal pieces. Centimeter. Okay? So doon na na-introduce yung mga ganong types ng measurement. Kasi sa English system, sa imperial system, 'di ba, meron silang inches, meron silang feet, no? Then meron silang acre, so on so forth, no? Which is it doesn't make sense, no? Hindi siya nagme-make sense kasi hindi equal yung distribution nila, no? Unlike kapag metric system, ang distribution nila ay factors of 10 lang, no? Meter, centimeter, 100 of a meter, decimeter, 1/10 of a meter, kilometer, 1,000 ng isang metro, 'di ba? So nagme-make sense kasi basically you just multiply the same measurement by tens, no? By powers of tens. Unlike in imperial system, hindi ganoon, no? Iba yung measurement for inches, iba yung measurement for feet. So sobrang complicated, no? So yan yung ginawa ng mga French revolutionaries, no. They eliminated all those confusing things, no, when doing measurement, and replaced it with something that makes more sense, no. Okay, yun yung metric system. Okay, so ang major improvement natin is that in the metric system, mas naging unified ang ating way of measurement, and at the same time, we can convert one measurement to another. Okay, mas madali na siya mag-convert, no? From meter to centimeter, divide mo lang sa 100, meter to decimeter, divide mo lang sa sa 10, no? Kilometer to meter, no? Multiply mo lang ng 1,000. So ganun lang, no? So mas napadali yung buhay ng mga traders noong metric system. Okay? And ito na rin yung ginamit ng mga scientists that time. Okay? Because ang scientists natin, hindi lang siya mga European, no? We also have scientists around the world, no? So, for example, sa India, no? During the Great Enlightenment period sa India, marami ring mga researcher doon na nakakontribute sa mga European counterparts nila, no? Even China, no? So yun, dito nagkasundo na lahat. Okay, so ito yung nagme-make sense. Ito gamitin natin. And then currently, In the modern era, we have the International System of Units now. So the major improvement in this one is that instead of using physical constants, they instead used universal constants na. So that if ever tayo ay maging interplanetary species, pwede mo gamitin yung measurement pa rin natin. Okay? Kunwari, yung some of you may live in Mars in the future, no? So yung measurement sa Earth, pwede nyo rin gamitin sa Mars, no? Okay. So yun lang yung difference with metric and the SI units, no? Instead of using physical constants, we use the universal constant, no? For example, yung meter, literal na yun yung size na yon, meter stick na yon. Okay? Paano nila define yung size na yon as the meter? Yung North Pole at equator, hinati nila into certain portions. Then yung size na yon, that's 1 meter daw. Yan yung napagkasunduan nila eh. Okay. Thus currently, right now, the definition of a meter is the fraction of a second, no? When it travels in a speed of light. Okay. So, yun yung definition ngayon ng isang metro. Okay. So, basically, ang mapapansin natin, no, ang summary ng slide natin na ito is that yung measurement, that was an arbitrary constant, no? When you say arbitrary constant, napagkasunduan lang ng mga tao, no? Na, ito isang dangkal, ito isang yarda, no? And then later on, no, since it was unfair, no, for some empires, no, napalitan yon ng metric system, no, wherein they defined specific physical objects, no, to be used for measurements, no. Okay, so yan, doon na nauso yung mga metric system, meters, kilometers, no. And then eventually yun ay na-convert into SI units, which we use in science, no. Because this is based on universal constants, no? Hindi siya based sa kung ano-anong bagay lang na ginawa ng mga tao dati. So, based na siya sa physical, universal constants rather. Okay? So, yun lang yung short history niya, ha? Anyway, so yan na nga, English system. May ganito pala. So, yan. So, English system, ito yung ginagamit sa mga, US, UK, Bangladesh, So, yan ay based on physical sizes, no? Pag sinabing metric naman, ito yung galing sa France, no? This is a product of the revolution out there. And ang isa pang important dito sa metric system ay yung decimal system, no? That all units of measurements can be related to one another by just factors of 10. Okay. Kasi sa tignan nyo sa imperial, yung isang feet, yung 1 feet, ilang inches? 12. Okay. Nagbe-make sense ba yun? Parang hindi, di ba? Okay. So, kasi kunwari, yung inches, i-convert mo yan into acres, iba pa yan, no? Certain number pa yan. So, ang hirap mag-solve. Unlike kapag metric system, urong-urong ka lang ng decimal point, tapos na yung conversion. Okay. So, mas madali for traders. No? By the way, these are the units in the metric system. We have 7 of them. And ito rin yung naging basis for the SI units. No? Okay. So, in units of length, we use the meter. Okay. And in terms of volume, ang ginagamit sa metric system ay liters. No? Okay. And then pag mass, naka-gram, time, second, temperature, Kelvin, energy is in joule, and amount of substance ay mole. So I will not go through kung paano sila na-discover. No? Meron naman sa Wikipedia. Pero yun yung idea. No? So they are products of the revolution. Okay. And ito naman, di ba remember, sabi ko kanina, in the metric system, we introduced the decimal system. Ano meron sa decimal? Factors of 10. No? Okay, so ano meron ngayon? Okay. So, itong factors of 10 na to, nakatulong to in measuring big distances for small distances, big objects and small objects, no? Even kahit atomic scale yan. So basically, ang gagawin mo lang is that you will determine by what factor of 10 i-multiply yung number, no? Or i-divide yung number. Okay. So for example, we have gigabyte, no? Gigabyte. Gigabyte. So ilang bytes 'yon? Eh di 1 billion bytes, no? Yung katumbas niya halos 1 billion bytes, no? Okay? So ibig sabihin nun yung isang byte, multiply mo lang by by 1 billion, you get the gigabyte na. Okay? Kunwari naman megawatts. Okay. So yung 1 watt, i-multiply mo lang sa 1 million, mega na siya, no? So you can measure bigger quantities na, no? Kunwari kilo o kilogram, no? So kunwari I have 1,000 grams, edi isang kilo 'yan, no? Okay. So factor of 1,000 kasi yung kilo. Deci, 1/10, centi, 1/100th, milli, 1/1000, pico is micro is 1/1,000,000th, nano is 1/1 billionth, and pico is 1/1 trillionth. No? Kailangan ba ito kabisaduhin? Kahit di na. Kailangan familiar na tayo dito. Okay? So, kahit huwag nyo na kabisaduhin. So basically, ang purpose na itong prefixes na to is to expand our metric system. So, yun yung goal niya. To expand the metric system. Okay? Sa imperial kasi, gagamit ka pa ng ibang units of measurement. Kunwari, inches. So, pag lumalaki na, feet gamitin mo. Pag lumalaki na, yard, no? Pag lumalaki na yung yard, gawin mong miles, no? So, iba-iba yung units of measurement. Unlike in metric system, gagawin mo na lang, multiply mo sa 10, multiply mo sa 100, multiply mo sa 1,000, may equivalent na prefix lang na idadagdag ka. Okay? Kunwari, nag-1,000 ka na, 1,000 na gram, di kilogram na katumbas nun. 1,000,000 na gram, di megagram. No? 1,000,000,000 gram, di gigagram. No? So, ganun. So, yan, may pang-expand na tayo ng metric system natin. And ito, since yun nga, some countries still prefer to use the English system or the imperial system. So, nag-establish na lang tayo ng conversion factors. Okay? For example, the inches is 254 cm, ang isang mile is 1609 kilometers, no? So on and so forth, no? Siguro you may ponder, no, na bakit kaya nag-English system pa rin sila, no? Especially the US, no? US is known to produce many great scientists, 'di ba? Pero bakit kaya sila nagme-metric system pa rin, no? And one short answer there is ayaw nila ng metric. Bakit? Convenient kasi sa kanila na hindi magpalit. Ang Americans kasi, they are quite stubborn. Kaya nga mapapansin nyo, mask, nagiging debate pa sa kanila. Samantalang sa atin, pag sinabi, mag-mask tayo, suot tayo ng mask. Sila kasi, they have this some sort of stubbornness. No? Okay, to be specific, no, I think this is in the Clinton administration, 1998 ata. No, they tried to push the use of metric system in the US. No, okay. Some legislators don't like English systems na. No? I think I'm mistaken, hindi siya kay Clinton, I think kay Nixon. No? Mga 1980s, 70s pa yan. So there are initiatives to convert the English into metric na sa US. Kasi ang problem, ayaw ng mga tao, no. Ayan, ayaw nila. Kaya until now, nagme-metric pa rin sila. Nag-i-English system pa rin sila. Okay? So yun lang. Pero in other countries such as the Philippines and countries in Europe, no, we use the metric system na. Okay. So hindi tayo magkakahirapan when it comes to understanding quantities. Okay. So yun lang. And then yun nga, sabi ko, SI system, this is based on the metric system. However, they improved it, no, so that they base these units into universal constants na. Okay. So hindi na siya physical object, rather we use physical universal constants na. Okay. Such as the speed of light, no? The Planck's constant, no? Ayun. So marami pang iba. Okay? So, ayan. With all those things, no, we can do different measurements of length, volume, and mass. Okay, so hindi ko na to daanan. Okay. So ngayon, punta naman tayo sa issue ng mass and weight, no? Kasi some of you may think na they are the same. Okay. Let's talk about mass and weight, no? When we say mass, um, this is the actual dami kong L. This is the actual content ng isang object, no? Ito yung actual na dami ng atom sa isang body niya. Okay? So when we say mass, ito yung ating mismong weight, no? I mean mismong quantity ng matter natin, no? Kunwari, I have 10 atoms. Yung bigat ng 10 atoms na yun na yung aking mass, no? So the mass is constant. However, when we talk about the weight, no, we have to account for the gravitational factor, no? Okay, we have to account for the gravitational factor. So ibig sabihin nun, you have the same mass, pero in different planets you will have different weights, no? Because of this gravitational factor. Suppose I weigh 100 grams, no? Isang kilo ng bigas. Ayan, kunwari, 100 grams ako. Sa Earth, I weigh 9.8 newtons, 1.8 kilonewtons. Pero sa Mars, I weigh 3.4 kilonewtons. Na. Mas magaan ako sa Mars kaysa sa Earth. Although I have the same mass. Na. Ito siguro magiging confused na naman kayo. Sir, bakit kapag sa biodata, yung weight nakalagay kilograms? Dapat Newton talaga. Okay? Dapat Newton kasi when you multiply the mass and the gravitational constant, no? Pag minultiply mo tong mass and the gravitational constant, this is equivalent to Newton units, no? Force units yan. So, actually, mali yung mga nasa biodata. Kasi di ba nakalagay doon weight, tas nakalagay kilograms, no? Dapat Newton. Okay. However, since we live in the same planet, no, and the gravitation constant is constant in this planet, no, so pwede na natin hindi pansinin yung weight, no. Pwede yung mass, gawin na rin nating weight, no. Kasi again, we live on the same planet naman. Okay. So basically, they just remove this factor. Okay. Pero in reality, that's very wrong. Okay? Mali talaga yon. However, for convenience, no, since nasa iisang planeta naman tayo, okay na. Dinisregard na nila tong G. No? Okay? So, pero in science, that's not acceptable. So, yun na. Ibig sabihin, kapag namamalengke kayo, no, dapat yung lumalabas sa timbangan, naka-newtons. No? Pero, naka-kilograms yon. Bakit? Kasi the gravitation constant is considered constant sa Earth, no? Okay? So, yun lang. So, in chemistry naman, we may interchange this, no? We may interchange the mass and the weight, no? Okay lang din naman. Okay? Ako nga, kanina na-interchange ko sila, di ba? Kasi, ang consideration naman natin is that we are on the same planet, no? So that's fine. Okay lang yan. However, keep in mind na yung mass and weight may difference talaga. Okay? Okay? So yun lang. Here are some examples, no? As you can see, ginawa lang dito is we computed for the weight. Di ko naman ibibigay yung ganitong problems sa quiz natin. No? Madali lang yung quiz natin. Okay. So, kunwari, you are, let's say 15 kilo ka dito. So, ano yung weight mo on Earth? So, weight is 15 kilo times the gravitation constant, 9.8 meters per second. No? Yan. So the weight is second square rather. And so multiply mo na lang yan, yun yung weight mo. And if you're on a different planet, let's for example Mars, no? Your gravitation constant there is 3.4 meter per second square. On Moon, ayan, on Moon that's 1.6, no? So you will weigh less in other planets but you still have the same mass. So isa na rin to sa pan-debunk sa mga nagsasabi na fake news daw ang pagpunta natin sa pagpunta nila sa moon. Kasi papansin nila, for example, pakita ko sa inyo, moon landings. May mga video kasi din sa moon landings natin na it seems na ang dali-dali daw buhatin ng ibang objects sa moon. Pero sa Earth, ang hirap buhatin, no? For example, itong suot ng astronaut na to, it actually weighs around 60 to 100 kilograms, no? Pero bakit pagdating sa moon parang effortless daw? Okay. What they don't understand is yung concept ng weight, no? They still have the same mass. However, in the moon, mas mababa yung weight niya sa moon kasi nga the gravitation constant is lower in the moon than on Earth, no? Sa Earth, 9.8 meters per second, no? Ito yung gravitation constant natin. Sa moon, 1.6 lang, no? Almost 1/10, no? Yung bigat ng mga objects sa moon kaysa sa Earth, no? So yun yung failure nila to recognize, no? That objects in the moon are lighter in terms of weight because of the lesser gravitational pull on the moon. Pero pag sa Earth yan, di yan kaya makatayo. Hindi nila kaya makatayo alone. So minsan sinusuportahan sila ng other people kasi super bigat niyan. Okay? So yun lang. When it comes to time, and time naging fix na talaga to. No? Short history na lang ng time. Nung unang panahon kasi, yung ating mga ninuno, no? So, ang basis nila ng time is the sunrise, no? And the sunset, no? So, ito yung tao. So, yan. So, sunrise, sunset, no? Yun yung basis nila ng time. Then, paggabi, hindi na nila alam kung anong oras na. No? So, kunwari, andito, so sabi nila, oh, that's noon time. Okay, andito, that's morning, no? Dito, gabi na, okay? Then, yung ating mga mga explorer, they use the astrolabe, no? Mga astrolabe in order to map the sky, no? So, ginawa nila, nilagyan nila ng fractions yung ating sky, no? Kaya, and each fraction, 60 minutes yung katumbas, no? So, kunwari, yung sun, mag-move mula dito hanggang doon, ibig sabihin nun, 60 minutes na nakalipas. No? So, basically, the daytime is divided into 12 sections. No? 12 ba? Yes, 12 sections. 6 a.m. to 6 p.m. So, dinivide nila yung sky into 12 sections and those sections ay alam natin ngayon as the latitudes. No? The latitudes. No? Okay? So, ganun lang. Medyo complicated yung time eh. When it comes to temperature naman, ito may history din to. No? Share ko lang yung short history. Kasi in science, we usually use Celsius and Kelvin. But for example, in the United States, they use Fahrenheit. No? So, bakit nga ba may ganyan? No? Bakit may Celsius? Bakit may Fahrenheit? Bakit may Kelvin? Ganito kasi yan, no? So, nung unang panahon, wala pa silang uniform way of measurement. So, kanya-kanyang gawa, no? Kanya-kanyang gawa ng measurements, no? So, tatlong tao yan, no? Si Julius Fahrenheit, if I'm not mistaken. Basta si Fahrenheit. And then we have si Celsius, no? Under Celsius ata, and then we have Lord Kelvin, no? From the United Kingdom. Okay, so ano kwento nila? So si Fahrenheit, ang naging basis niya ay body temperature. Body temperature daw. Okay, so nag-set na lang siya ng random number. Okay, nag-set na lang siya ng number. Okay, so sabi niya, kapag normal body temp, sabi niya, 100 yon, 100 Fahrenheit. Ayan, normal body temp yon. And then kapag yung winter, ayan, sinasabi niya yon. So pag winter, that's 0 Fahrenheit. Okay, so ganun lang daw. Yun na yan. Tapos anything in between is siya na yung nag-interpret ng kung ano-ano. Okay, so yun yung ginawa ni Fahrenheit, no? So, ang kanyang basis for his measurement is the body temperature, no? And the winter environment, no? Sa Europe. Okay. So, ngayon, punta naman tayo kay Celsius. Si Celsius, nag-try siya nag-isip ng mas universal na approach, no? Kasi inisip niya, kapag body temperature, iba-iba yan eh. Okay. Kunwari ako, mainit talaga, no? O kaya, malay mo, may lagnat na pala ako. 100 Fahrenheit pa rin yung basis mo doon, no? So, in order to make everything uniform, sabi ni Celsius, instead of using body temperature, I will use water. Yun sabi niya. Tubig na lang kaya yung basihan ko. Kapag kumulo yung tubig, yun yung 100, no? So, pag nag-boil, 100. And then, kapag nag-freeze, 0 degrees Celsius. Okay. And actually, scientists accepted Celsius scale, no? Ginamit nila yung Celsius scale, no? Kasi, hulaan niyo bakit? Kasi yung tubig ay everywhere, no? Ibig sabihin, wala ka man na thermometer mismo, you can devise your own, no? Kasi you have water as the basis, no? Yung tubig naman sa ibang bansa, same lang yun sa tubig dito, no? So, ibig sabihin nun, wherever you go, you can actually attempt to create the Celsius scale. Kasi ang basis niya ay water, no? Unlike kay Fahrenheit na body talaga, ang tanong kasi doon, sinong body? Kaninong body, no? Kailangan ba may lagnat? Kailangan ba walang lagnat, no? So, yun yung mga problems with the Fahrenheit scale, no? Pero kapag kay Celsius, tubig lang, tubig is everywhere, you can replicate the scale, no? Okay? Then, lagyan mo na lang siya ng graduation, no? Yung mga fraction. Si Kelvin naman, ito ay mga early 19th century na to, no? Kasagsagan na to ng revolution sa science, no? The quantum field, no? The quantum science. Anyway, kasabay yung mga ganung mga modern scientist, no? So bale, ang ginawa ni Kelvin, instead of using water, ginamit niya atoms. Masyado siyang ambisyoso. Atoms talaga yung ginamit niya, no? Pero due to that ambitiousness, may word bang ganun? Yung kanyang ambition, yun yung naging reason bakit Kelvin yung ginagamit sa science, no? Bakit? Kasi lahat naman ng bagay gawa nga sa atom, totoo naman, no? Ang idea lang ni Kelvin is that kapag yung atom hindi na gumalaw, ibig sabihin nun, yun na yung absolute zero. Walang temperature reading kapag ganon. 0 Kelvin. Okay. Yun yung sinabi niya lang. Kapag yung atom hindi gumalaw, 0 Kelvin yun. Kapag yun ay gumagalaw, ibig sabihin may temperature, yun na. Okay? So kapag mainit, magalaw masyado yung atoms. Pag malamig, mabagal gumalaw. Pag hindi na gumagalaw, absolute 0. Okay? Ginawa lang ni Kelvin is inadapt niya rin naman yung idea ni Celsius. Similar lang din, pero in terms of atom yung kanyang interpretation. So actually, medyo complicated pa yon sa sinabi ko. Pero yun lang yung idea. No? Si Fahrenheit, body temperature ang ginamit. Pero medyo problema yon kasi sinong tao, kaninong katawan, yung basis for temperature. Si Celsius naman, tubig yung ginamit. And because tubig is everywhere, ginamit ng lahat ng tao yon. Okay? So, yan. And until now, we use that na. Kasi we can create our own temperature scale just using water. And then si Kelvin naman, atoms yung basis niya. So, he tried to improve the Celsius scale in terms of atomic level now. Okay, so he interpreted that there will be a time wherein the atom will no longer move and that is the temperature called the absolute zero. Hindi nagagalaw yung atoms nun. Okay? So, yan. So, ngayon, ang problema, paano ka magko-convert from Fahrenheit to Celsius, Celsius to Kelvin, Kelvin to Fahrenheit, vice versa? Paano mo nagagawin yan? So we have several formulas, which is again, huwag nyo nakabisaduhin kasi sayang yung brain cell. Pag nag-quiz naman kayo, open notes naman yan eh. Okay. Hindi ko naman kayo makikita nag-quiz. Okay. Basta mag-take kayo. So in order for us to convert one unit into the other, we use several conversion factors. If you may ask, paano sila dinerive? Medyo complicated. Pero basically, they tried to determine the relationship between the two scales. No? So, ganun lang ginawa nila. Nag-ratio and proportion lang sila until they came up with these formulas. Okay? So, again, no need to memorize kasi open notes naman kayo pag nag-quiz. No? Ang gusto ko lang is malaman nyo how to really use these equations. Okay? Ayan. So for example, we have this question. Again, yung tayo mismo magso-solve sa Thursday na lang ha. Pero for now, itong PowerPoint lang muna gagamitin ko. Okay. Pero yung solving Thursday na tayo na. Okay. So anyway, for example, we are asked to convert this temperature Fahrenheit to Celsius, no? So 98.6 degrees Fahrenheit, convert mo daw to Celsius. So basically, gamit ka ng ibang gamit ka ng mga equations dito. So, Fahrenheit to Celsius, ito yung gagamitin mo. Kasi Celsius yung masosolve mo, no? Okay? So, ito daw gagamitin natin. So, ayan. So, basically, you just plug in the Fahrenheit here and then you will get the Celsius equivalent na. Okay? So, for now, babasahin ko lang muna talaga yan. Thursday, dun tayo magsosolve mismo. Okay? So, sabay-sabay tayo magsosolve. Okay, so ayan naman, this is from Celsius to Fahrenheit, no? Basically, you use this equation instead, no? This is the Celsius to Fahrenheit. Ayan, so you use this equation. Plug in lang naman. Okay? And for Kelvin, ang Kelvin kasi, since that was similar with the Celsius scale, no? So, ito lang yung ginamit nila. So, si Kelvin, ang ginawa niya lang, nag-add lang siya ng factor na to, 273.15. Why that number? I'm afraid I don't have an answer for that, pero I believe no na that was derived actually no in the gas laws no. Pag nag-gas law tayo, mababalikan uli natin tong 273.15. Okay. Yan. Walang sagot pero may sagot din. Pero yun yung idea na in-extrapolate lang nila yan. No? Nag-solve lang sila. Papakita ko uli yan pag nag-gas loss tayo. Okay. So yan lang. Again, don't memorize this. Gawa na lang kayo ng index card containing all the equations. Then by Thursday, we will answer several problems. No? Okay. So I'll upload those questions by Wednesday. Then Thursday, sagutan natin. Okay, next one is the density. No? So pag sinabing density naman, this is the ratio of mass and volume. Na? So ganun. So this is the ratio of mass. Oopsie. Okay, so this is the ratio of mass and the volume. Na? For metric system, mass is usually expressed in diba, in grams, no? And the volume, that's usually represented in liters, no? Kapag metric. However, in chemistry, na metric system, we don't use liter. Rather, we use the milliliter. Okay, we use the milliliter. Okay. So, ganun. So, instead of using grams, instead of using liters, we instead use the milliliters. Why kaya, no? Ang reason is that, ang chemicals na ginagamit natin, hindi naman litro-litro, no? Usually nga, patak-patak lang, no? So, using liter scale will not help, no? Kaya, we will use instead the milliliter scale, no? Again, milliliter, that's 1/1000th of a liter. Okay? So, ganun lang. And the volume, sometimes kapag solids yan, pag regular solids yan, if we have a regular solid, then may mga equations to solve for the volume. If that's prism, that's length with height. Kapag yan ay sphere, that's 4/3 pi r cube, no? So, ituro ko yan sa inyo sa susunod na meeting, okay? Or kapag may time pa tayo ngayon. So, ituturo ko uh, how to incorporate this volume equation for the regular solid into the density equation. Okay. So again, the metric unit for the density is grams per ml, but the SI unit here is kilogram per cubic meter. Okay, kilogram per cubic meter. Okay, so yan. So another thing is a specific gravity. No? So ano naman meron sa specific gravity? So in a specific gravity, what happens here is that ano lang, you just divide your density by 1. No? It has no units, no? And mostly ang gumagamit nito ay medtech, no? Kunwari nag-urinalysis sila, no? In urinalysis, instead of solving for the density, what they actually do is they solve for the specific gravity. Okay? So ganun lang. Wala naman siyang pinagkaiba with the density. Ang pinagkaiba lang is wala siyang unit, no? Bakit kaya? Kasi you just divided it by the density of the water. And we know that the density of water is 1 gram per ml. Okay. So, kunwari, density ng urine, 1.9 gram per ml. Divided by 1, basically 0.9 lang din yan. Okay. So, yun. Saan to ginagamit? Medical sciences. No? So, dun siya ginagamit. Okay. So, yan yung ibang solving. I'll give you worksheets on that. Okay. And so basically, that is the history of measurement and how we do measurements now. Okay. Kung may question kayo about measurement, you can raise them. I think ito yung worksheet na gagamitin natin. Ay, hindi, wag to. Ang dami masyado. Alam ko may ginawa akong isa pang worksheet na onti lang eh. Ayan. So, we have this worksheet. I will upload this sa ating Canvas now. So, upload ko na nga ngayon pa lang para may copy na kayo. Wait lang. Upload ko para may copy na kayo. Then, I will try to answer some questions no? Dito sa ating worksheet. Then, yung iba kayo na bahala. Lab ito. Wait lang, upload ko sa Canvas. So, open na kayo ng Canvas. May upload ako. Discussion. Sa discussion ako maglalagay. Okay, so ayan na, naka-upload na sa Canvas. You can download it. Punta lang kayo sa discussion. So I'll try to answer one problem. Okay. Few problems para ma-practice natin. So ngayon na tayo mag-solving. Marami pa tayong time eh. Hanggang 1:30 pa tayo. Kuha lang ako ng, saan kaya ako pwede magsulat? Adobe na lang. Doon na lang ako magsusulat. Adobe. Samahan niyo ako mag-solve. If you have calculators with you, that will be good. No? Solve tayo. Ngayon na. Kasi ang dami pa nating oras. Let's try this problem. Ayusin ko lang yung Zoom. Ayaw talaga. Ganyan na lang. Mababasa nyo naman siguro, di ba? A solid with an irregular shape and has a mass of 11.3 grams is added to a graduated cylinder filled with water. The density of water is 1 gram per ml. To the 35 ml mark, after the solid sinks to the bottom, the water level is read to be at the 42.3 ml mark. What is the density of the liquid? Sige, I'll give you time to try to answer this, then solve ko. Okay? So, bigyan ko kayo ng 3 minutes. Comment kayo sa box, sa chat natin kapag may sagot na kayo. Okay? Madali lang yan. Two minutes na. So, yan. You have the question here. Ayan, nasa chat box natin. I have the question. You can send your answers. No? Hindi naman nata makikita ng iba yung answers niyo. So, okay lang kung magkamali. You have 2 minutes pa to answer. Then I'll explain how we will arrive with the correct answer. Ayan, mas malaki. Okay, so 3 minutes na. Ano mga sagot niyo? Okay, somebody answered 1.6. Okay. Nakita pala yung mga responses niyo. Okay, Chris, Daylin, 1.6. How about the others? How about the others? 35, 11:35 sabihin ko na yung sagot. Pakita ko yung solving. For the others, try to participate para sulit yung tuition. So we have one answer already. Waiting for others. Okay, so I think yung iba busy pa, no? Sige, so let's try to answer this problem. So madali lang to. As in, madali lang talaga. I'll try to reduce the text size. Anyway, so ganito lang ganap dyan. So you have a graduated cylinder. So I know everyone knows how it looks like. No? So ganyan yon. So this is the graduated cylinder filled up to 35 ml mark. Okay. So yan yung ating graduated cylinder. Ayan yung kanyang initial volume. Then I have an object. No. Itong red object na to. I have an object that weighs 11.33 grams. No? Tapos ano daw ginawa dito sa object na to? Sinubmerge. No? Nilagay dun sa loob. Walaan nyo anong mangyayari. Siyempre, lulubog siya. Then, nung lumubog siya, what happened is that the water level rose to 42.3 ml mark. So from 35 naging 42.3 ml na siya. Okay. That is displacement na. So na-displace siya, no. Okay. So ngayon, ang tanong sa atin, what is the density? What is the density? What is the density? Density. Okay, madali lang 'yan. Okay. Kasi alam natin that density is equal to mass over volume, 'di ba? Ano yung mass ng object? That's 11.33 grams. Ngayon, the question is, ano yung volume niya? Okay? So ano kaya volume niya? Saan natin makukuha? O anyone? You can chat or open your mic. Saan kaya natin makukuha yung volume? Okay. So saan kaya natin makukuha ang volume? Ang volume ay makukuha natin sa displacement. Okay. Ay iba busy pa ata. So itong displacement na to, this can actually tell us the volume. Okay. Yan yung volume of the solid, no? So dyan yun makukuha. No? And the volume of the solid can be obtained dyan sa displacement, no. I don't know if familiar kayo dun sa Archimedes principle. Familiar kayo sa Archimedes principle? Naalala ko to kasi ito yung unang lesson namin noong first year high school ako. 14 years old pa ako nun. Okay. So naalala ko that time tinuro sa amin ang Archimedes principle. Okay. So ang kwento ni Archimedes is that ang question sa isip niya, paano ko kaya makukuha yung volume niya, yung volume ng katawan ng tao daw. So isip-isip siya, tapos naligo siya, humiga siya sa bathtub, sana all may bathtub. Pagkahiga niya, yung water na displace, okay, may natapon. Okay, so ibig sabihin may na-discover daw siya, no, that the water displaced, no, is equivalent to the mass. Is equivalent to the volume of the person. Doon yung sinasabi na eureka, no. So na-discover niya, no, eureka, I found it, no. Para nahanap niya yung solution sa question niya. That the displacement of water is equivalent to the volume of an object, no, of an irregular object. So yun yung Archimedes principle. So that means whatever the displacement here, yung change sa volume, that is the volume of the object itself. So to get the volume of the object, that is yung final volume minus the initial volume. Okay, so 42 minus 35 now, which is Ilan ba? 42 minus 42.3, 35, 7.3. So this is 7.3 ml. Okay? So yun yung volume ng object na yan. So 7.3 ml. So all you have to do now is to divide the mass by the volume to get the density. So 11.33 divided by 7.3, we get 1.55 grams per ml. Okay? Or 1.6 now. Okay, so 1.6 then. Okay, so yung sagot ni Chris, ano yung Chris Daylin ay correct na. Oh, how about the others? Nakuha nyo ba? Paramdam naman yung iba. Nakuha nyo naman ba yung answer natin? Okay, malinaw na. Siguro nag-isip pa kayo na ano kaya nangyari? Ay, sa ganun lang ginawa niya. Displacement method. Let's try another problem. No? Let's try this letter C. Ito, tricky problem ulit to. Ngayon na tayo nagsasagot kasi medyo marami pa tayong time eh. Okay, ayan. Let's try to answer this. A metal slug weighing 25.17 grams is added to a flask with a volume of 59.7 ml. Okay. And then it is found out that 43.7 grams of methanol must be added to the metal to fill the flask. What is the density of the metal? Okay, so again, I am going to post the question and then try to answer. I'll make it, sige, okay na yun. Tayo lang naman nandito. So you have the question there with you. A metal slug weighing 25.17 grams is added to a flask with a volume of 59.7 ml. It is found that 43.7 grams of methanol must be added to the metal to fill the flask. What is the density of the metal? Ito medyo mahirap to, no? Kaya ako na siguro sasagot. Pero habang nagsasalita ako, you can try. Send nyo na lang yung answer nyo. Okay? So, ayan. Bibigyan ko kayo ng idea paano sagutan to. Then, antayin ko yung responses nyo. Again, okay lang magkamali, no? Tayo lang naman nandito. Magkakakilala na naman tayo. Okay. So, ang kwento lang dyan, ang metal slug, ano lang yan? Represent mo na lang yan as a circle. By the way, sa chemistry, uso mag-drawing. Kahit pangit, okay lang. Mahalaga ma-visualize mo. So, this is the metal slug, kunwari. And it weighs 25.17 grams. No? O yung flask, gawin na lang nating ganito. Kunwari, Erlenmeyer flask yan. So, ito yung flask natin. And the volume ng flask ay 59.7. Total volume. Ganun sa, ayusin ko lang yung aking drawing. Drawing lang tayo para mas ma-visualize yung problem. Okay lang kahit pangit ang drawing. Okay? So, ang total volume ng flask, 59.7 ml. Okay. Tapos, ano ginawa? yung slug, yung bilog na yon, nilagay dito. Pinasok nila dyan yung slug. And then, to completely fill the flask, sabi ni problem, naglagay daw siya ng 43.7 grams ng methanol. So, nag-add siya ng 43.7 grams ng methanol. So, nilagay niya yung slug, then para mapuno yung flask, naglagay siya ng 43.7 grams na methanol. Ano daw yung density ng metal? Okay. Parang displacement method to, no? Parang yung kanina, pero medyo mas mahirap to. Okay. Bigyan ko kayo 5 minutes, no? 11:50. Wait ko yung answers niyo. Okay. So for now, yan yung visuals. And hopefully dito sa visualization natin, makita nyo kung paano nyo siya solve. No? This is displacement method pa rin to. Displacement method. Yung ginawa natin kanina, ganun din. Okay. Wait ko na lang answer nyo. 11:50, babalik ako. Okay, so it's already 52. Let's check. Si Chris, may answer. Yung iba, wala pa rin. Okay lang naman. Siguro nagsasolve pa kayo na or hindi pa familiar kung ano yung magiging step natin. Wait lang. Just charge this lamp. Okay, so how are we going to answer this problem? No? Okay, ganito lang. Medyo mahirap to actually. Okay, so allow me to clear up some space and let's answer. Ganito lang ginawa, no? So, bale, balik tayo dito. Ang gusto natin ay density ng metal. Density ng metal equals mass ng metal over volume ng metal. Okay na yung mass. Ito na yun, no? 2517. Pero yung volume, paano kaya? No? You may ask. So, pag gusto mo kunin yung volume ng metal, punta tayo dito sa illustration natin. Ang idea lang dito is may container ka, nilagay mo yung bakal, then to completely fill the container, I added methanol. Okay? So, ganun ginawa ko. So, parang ganito lang yan. Ito, alcohol. Lagyan ko dyan ng Jolen. Okay? Tapos, para mapuno itong lalagyanan na to, lagyan ko ng alcohol, no? Parang ganun yung ginawa niya dito. So, bale, ang mangyayari, yung total volume ng flask, no? Yung total volume ng flask ay yung volume ng metal plus the volume of methanol. So, ganun mangyayari. Kasi yung nasa loob ng flask ay 59.7 ml total. So, yung ilang portion doon kay metal. Yung ilang volume doon kay metal. And then yung iba kay methanol. Okay? So, yun yung idea. Ngayon, paano kukunin yung volume ng methanol? Punta tayo dito sa second sentence. It is found that 43.7 grams of methanol must be added to fill the flask. Okay? So, ito yung idea. Para malaman mo yung volume ng methanol, pwede mo yung makuha gamit yung kanyang mass. 43.7. So, yun yung gagawin natin exactly. Mababa lang unti tayo. So, kunin ko yung volume ng methanol. Gamitin ko yung density formula. Density ng methanol, mass ng methanol, over volume ng methanol. Ay, gusto ko volume So, anong gagawin mo? Cross multiply. Okay? So, you have here the volume of methanol equals mass ng methanol over density. Okay? Nakita niyo yung ginawa ko? Cross multiplication lang. Algebra lang yan ha. So, I hope kaya nyo na yan. Cross multiply lang. Kasi volume yung kailangan ko. Bakit ko kailangan yung volume ng methanol? Kasi gamit yon, pwede ko malaman yung volume ng metal. Okay? So, yun lang yung unang gagawin natin. Okay, so yan. Ano yung mass ng methanol? 43.7. Ano yung density ng methanol? Sinabi sa problem yung kanina. Sabi sa problem ay 0.791. 0.791. Okay? Divide ko lang, makukuha ko yung volume ng methanol. 43.7.791. So, dalawang beses ako magda-density equation. Okay? So, yan yung trick dito. 55.25 ml. Ito yung volume ng methanol. Okay? So, yan yung volume ng methanol. 55.25. Balik ulit tayo dito. Ano yung total volume ng flask? Total volume ng flask ay equal sa volume ng metal plus volume ng methanol. Alam ko yung volume ng flask. Alam ko yung volume ng methanol. Ibig sabihin, pwede ko malaman yung volume ng metal. Okay? So, to get the volume of metal, that is simply the volume of the flask minus the volume of methanol. Okay? So, ganun lang. Ito, lipat mo lang sa kabila. Algebra lang. Okay? So, ganun lang ginawa ko. So, ano yung volume ng flask? Ang volume ng flask ay 59.7 ml. Ang volume ng methanol ay 55.25 ml. So, makukuha ko na yung volume ng metal. So, subtract ko lang. 59.7, 55.25, 4.45 siya. 4.45 ml. O, yun na yung volume ng metal. Tapos na ba ako? Hindi. Hindi pa tapos. Ang dami lang process, no? Pero sasanayin ko kayo sa ganito, no? Maraming ginagawa sa isang problem. Para mas lalong ma-enhance yung ating skills, no? Ang gusto ko, density ng metal. Nakuha ko pa lang sa lahat ng ginawa kong to, volume ng metal. So to get the density of metal, madali na lang. Madali na lang. Ano gagawin ko? I-ano ko na lang, i-divide ko na lang yung mass sa volume, na nakuha ko na yung volume eh. Zoom in tayo dito. So ano yung mass ng metal? 25.17. Ano yung volume ng metal? Volume ng metal, hindi ko kabisado, 4.45 ml. So 4. See. Ano yun? Divide mo na lang. 25 divided by 4. Ganun lang kasimple. Okay. So I think siguro pag nahihirapan pa kayo, meaning yan nag-a-adjust pa kayo. Okay lang yan. No. Sa ngayon nag-a-adjust pa kayo. But hopefully in the future, sanay na tayo. No? So the correct answer is 5.65 grams per ml. So acceptable yung answer ni Chris. No? So yan. So ganun lang. Maraming gagawin pero masasanay din kayo. So, gaya nga ng sinabi ko kanina, ang chemistry, mas maintindihan mo siya when you do drawings. Kahit pangit yung drawing mo, okay lang yan. Mahalaga na nakikita mo, na visualize mo yung process. Okay? So, do we have any questions with regards to this question? Or okay na, nakita na kung paano sagutan? Okay. Yes, Leisha.
Sir, paano po ulit nakuha yung 55.25?
Yun sa methanol. Ito.
Okay.
So, di ba kanina, ang meron tayo, density ng methanol, tapos yung kanyang mass. Kasi yun yung sinabi niyo dito, yung mass eh. So, para makuha mo yung 55.25 na yun yung volume ng methanol. So, dito lang yung ginawa na. Ito. Density is equal to mass over volume. Kung gusto mo hanapin yung volume, cross-multiply mo doon. Okay? Oopsie. Ay, wala na nangyari. I-cross-multiply mo. Ito, lipat mo dito. Ito, lipat mo sa baba. Okay? Hindi ko malipat eh. So, you will get this equation. V equals mass over density. Then yan, plug in na. Bigyan ko kayo ng technique. Although, feeling ko alam na ng iba to sa inyo. Triangle. Sa chemistry, maraming triangle. Hindi ko alam kung gawa ng Illuminati o. Okay. Okay. Paano i-interpret tong triangle na to? Mass, density, volume. Pag magkatabi, multiply. Pag isa nasa taas, isa nasa baba, divide. Okay. Tatakpan mo yan. Hinahanap ko density. Takpan ko to. Since density hinahanap ko, mass divided by volume yan. Okay. Mass divided by volume. Ngayon, hinahanap ko yung volume ng methanol. Hanapin natin yung volume ng methanol. So, takpan ko to. Mass divided by density. Ayun yung ginawa ko. Mass divided by density. So, ito yung mass ng methanol. Sabi sa problem, 43.7. Density ng methanol, sinabi din sa problem, 0.791. Divide mo yon, you get 55.25. So again, kung bago lang to sa inyo, ayan, so sana matutunan natin gamitin to. Marami pang ganyan sa chem na kung ituturo. Pag hinahanap yung volume, mass divided by density. Pag hinahanap yung density, mass divided by volume. Pag hinahanap yung mass, volume times density. Okay? Okay na ba tayo doon, Leisha? Nakita mo na paano na-solve?
Okay po, sir. Thank you po.
For the others, kung may katanungan, okay lang. Para sulit yung tuition. Kasi college tayo eh. Pag college, itanong nyo na lahat ng kailangan itanong para sulit. Kasi next week, start na tayo ng quizzes. Okay, so I think there are no other questions. Okay, so ganun. Ganun lang. Kung may tanong pa kayo, ask na kayo ha. Okay. Siguro punta muna tayo with the next part of my discussion. This is about significant figures. Scientific notation and significant figures. Okay. And then yung conversions, no. Siguro sa ibang part na to, magre-recording ako na para mas lalong ma-enhance yung inyong idea. Pero for now, I will go through the slides muna. Okay? So, ganito. Let's talk about scientific notation. If you are measuring distances, no, super layo, ang daming zero. Okay? Maraming zero lalabas. Okay? Kunwari, let's say, if you want to measure the cruising altitude, no, of the cruising altitude of aircraft, no, so that's 35,000 feet, no. Ayan. So okay lang kasi tatlo lang yung zero eh. Pero what if I will ask you, no, to express the number of atoms in a mole of a substance? So that will be 6022 tapos 23 na zero. 1, 2, 3, 4, 6. Basta ayan, ganun karami. So 23 na zeros meron tayo dito. Okay? So 23 decimal places. Ano yung problem when we're dealing with big numbers or when we're dealing with small numbers? The problem is that kunwari, mawalan ka ng isang zero, ang laking ang laking difference nun. Baka isipin nyo, ay isang zero lang yan, 10% lang yan. Pero hindi, no? In doing science, yung 10% malaki na masyado yung change na yun, no? So, kunwari, 100, tapos nasulat mo 10, sabi mo, ay 10% lang naman yung mali, no? No, ano yan, malaking difference yan, no? Okay? So, ibig sabihin nun, kailangan careful tayo with zeros, no? However, if we are dealing with so many zeros, hindi may iwasang magkamali, no? Pag super daming zero, hindi may iwasang magkamali. So, ano ginawa ng scientist, no? we are using scientific notation to minimize the errors when it comes to zeros, no? And kasi ang daming zeros sa science, no? Wag naman sana yung quiz score natin. Pero ayun, maraming zero na sinusulat sa science before. So in order to eliminate the issue sa pagbura ng isang value dyan, we use the scientific notation. So what is a scientific notation? So basically, it comes in this format, n times 10 raised to the exponent. So itong capital N, this is the integer, and it has values ranging from 1 to 9.9999, so on and so forth. Okay? So yun yung acceptable value niya, 1 to 9.99999. Okay? So yun. And then we have this times 10. So this is the exponential form raised to n. The small letter n, the exponent, tells you how much movement yung ginawa mo sa decimal point, no? Kasi remember, may numbers tayo, may decimal point yon. Kunwari, 1001, asan yung decimal point nun? Andito. In order to make this a scientific notation, you have to move the decimal point, no? In our case, to the left, no? Ilang steps? Tatlo. 1, 2, 3. So since I move my decimal point to the left, 3 steps, no? 3 steps to the left. So this small letter n will be 3. Okay? So ibig sabihin yung exponent na n na yon, ano yan? It tells you how many decimal movement you made, no? To get the final answer. Ilang step yung ginawa mo to the left or to the right, no? Para makuha mo yung gusto mong scientific notation. Okay, so ito yung mga common question doon. Sir, kailan kami hihinto sa pag-move ng decimal point? Hihinto ka sa pag-move ng decimal point once you have this value for integer. Okay? Once na mayroon kang value from 1 to 9. Okay? Hanggang dun lang kasi pwede. So for example, 1001, if I move my decimal point here, tapos na ba yun? Hindi. Kasi this is 100. And 100 is greater than 9, di ba? So ibig sabihin, isang urong pa. O, urong ko uli. Ayan, urong ko uli. Okay na ba yan? So this will become 10.01. Pwede na ba yun? Hindi pa rin. Kasi 10 is greater than 9. So ibig sabihin, I still have to move again. Move ko dyan. So this will become 1001. 1.001. Is this acceptable? Yes. Kasi pasok na siya dito sa 1 to 9. Okay? So since I moved my point to the left 3 times, so that will be times 10 raised to 3. Okay. O, paano naman kapag to the right ang movement? Pag to the right, that is a negative value. Okay. 1 step to the right, negative 1. 2 steps to the right, negative 2. 3 steps to the right, negative 3. No? So, bigyan ko pa kayo example dito sa baba. Let me erase this thing here. Okay. For example, zoom in. Ano ko pwede mag-zoom in? Zoom in tayo dito. We are asked, no, to express this number into the scientific notation. Ay, hindi pwede magsulat kapag naka-zoom in. Okay. So anyway, so ang idea lang dito is ganito. Ito decimal point. You have two options. Saan mo i-move siya? To the left, to the right, no? Ang kailangan kasi, yung resulting number ng pag-move mo ng decimal point ay between 1 to 9. Okay. So if I move my decimal point to the right, hindi pwede talaga. Kasi mas lalong magiging malaki yung integer ko. So kailangan 1 to 9 lang. Okay. So this decimal point must be moved to the left. If I move this here, Pwede na ba yun? Hindi. Kasi 56 yan eh. 56.8, which is greater than 10. I mean, greater than 9. So, hindi pwede yun. I move my decimal point again here. That becomes 5.68. Pwede na ba yun? Pwede na. Pwede na yun. If I move my decimal point from there to here, that's okay na. That's acceptable. 5.68. Kasi that is within 1 to 9. Okay. Basta pasok sa 1 to 9. Ayan yun. Then times 10 raised to 2. Bakit 2? Kasi I move the decimal point 2 steps to the left. 1, 2. Ganun lang. 1, 2. So ngayon, dito naman tayo sa number sa baba. If you have this small number here, how will you make it in scientific notation? Again, move your decimal point so that you will have a number between 1 to 9. So, pag minove ko to the left, hindi pwede. Mas lalong magiging maliit yung number. So, I want to move my decimal point to the right. No? So, how many steps should I take? 1, 2, 3, 4, 5, 6. Pagdating mo dito sa point na to, stop ka na. Kasi yung decimal point, magiging ano na yan, nandito na. So, the number will read as 7.72. Dito na mapupunta yung number eh. Okay? So, how many steps did I take? 6 to the right. Okay? Again, pag to the right, negative ang kanyang value. Negative 6. Okay? So, 6 steps to the right, negative 6 yung katumbas nun. 2 steps to the left, positive 2 yung value nun. Okay? So, ganun lang. Okay, so I would like to open again my whiteboard. Let's practice some items now. Practice tayo. Okay, so dito tayo. Suppose I have this number 631,004. Ay, hindi, wag na 4. 0. Ayan. How will I convert this into a scientific notation? Okay, so always remember, pag ganyan lang yung number, nasa dulong right yung decimal point. Okay. Okay. Could you try to make this into a scientific notation? Then I will answer this. I'll give you 1 minute now. I'll give you 1 minute to answer this. So this is 6.31 times 10 raised to 6 according to you. I mean 6 times 10 raised to 6 pala. Okay, so let's check if that is correct. Okay. So again, kapag wala ka nakitang decimal point, most likely nasa right end yun. Ikaw na maglalagay nun. Okay, so the goal is I want to create the integer. Kailangan yung integer ko ay within 1 to 9. Move tayo. Pwede na ba yan? Hindi. Hindi siya pwede. Urong ka pa. Pag dito, hindi pa rin pwede. Dito, hindi pa rin pwede. Dito, hindi pa rin pwede. 631. Dito, hindi pa rin pwede. 63.1 yan. Dito, pwede na. So, dito na yung aking bagong decimal point. So, that's 6.31. Tama kayo doon. Times 10 raised to how many steps? Bilangin natin. 1, 2, 3, 4, 5, 6. So, 6 steps to the right, that means positive 6. Or kahit wag mo na isulat yung positive, no? 6 na lang. So, that's how you write scientific notations, no? And so, basically, tama kayo lahat na. Okay, so that's good. Okay, so let's try another number. Let's try another number. Let's have 0.000000007. Ayan. So we have 0. Ayan. Then 751. I want you to convert this into scientific notation. Let's try to convert this into a scientific notation. Bilis niyo mag-ano na. Ayan. Madali lang to, na. Siguro familiar na kayo dito. Okay. So the answers are coming. Let's try. So again, I should make an integer of number between 1 to 9. So it should be somewhere here. 7.51. Ang tanong, ilan? Ilang steps? To the right ako. So ibig sabihin negative yung exponent ko. Ilang steps? So 1, 2, 3, 4, 5, 6, 7, 8, 9. Ayan, 10 steps to the right, no? So ibig sabihin nun, that's negative 10. So basically, tama kayo lahat ulit, no? And so very good, no? So ganun, that's how we write scientific notations. Again, why do we need scientific notations? Kasi kapag super daming zeros, mahirap, no? Nakakaduling. So that's why we change that, no? Ginawa natin ganito na lang. Okay? So, ayan. Marunong na kayo magsulat ng scientific notation. So, ibig sabihin, madali na lang ang susunod na. Next one. When we do operations with scientific notations, pwede natin sila i-add and subtract, pero may rules. Okay? Ito, siguro ngayon lang nyo to may encounter. Okay? Multiplication, division, may rules din. Pero madali lang. Okay? So, ganito. Start tayo. Addition and subtraction of scientific notation. By the way, 12:30, dismiss ko na kayo. Okay. Let's try. I'll try to cover it up to 12:40, 12:45 na. Kasi gutom na rin ako. Di pa ako nagbe-breakfast. Anyway, so sagutan natin. Paano tayo mag-add and subtract, no? So in order to add and subtract scientific notations, ganito lang. To add or subtract using scientific notation, write each quantity with the same exponent n. Ano meaning ng same exponent? Kung magkaiba sila ng exponent, pagpaparehasin mo pa. Okay? Pero kung same na sila ng exponent, kopyahin mo na lang. Okay? So, I'll go with specific examples. Babalik ako sa aking whiteboard. Okay? So, this is for addition and subtraction. Okay? So, addition and subtraction. So, alam ko bago pa lang to sa inyo, kaya wait lang kayo. Okay, so addition, subtraction tayo. Let's say we have 7.31 times 10 raised to 2 plus 3. Wag na 3. Ano na lang, 1.1. Suppose we are asked to add those two quantity. Sabi ni addition and subtraction, gawin kong same exponent muna. Okay? If you have the same exponent, 3 yan, 3 ayon, wala ka nang gagawin. Kopyahin mo na lang. Okay? So, kopyahin mo na lang yan. Okay? So, yun yung rule. Same exponent pag add, subtract. Okay? So, yan. So, times 10 raised to 3 to. Times 10 raised to 3 yon. So, kopyahin ko na lang. Times 10 raised to 3. Then, susunod, yung aking integers, i-add ko sila. 7.31 plus 1.1. So, kopyahin ko lang yung exponent, pero i-add ko yung integers. Okay? So, what's 7.31 plus 1.1? That is 8.41 times 10 raised to 3. Okay? So, ganun lang. Same exponent, add the integers. No? So, yun yung rule kapag addition. Ngayon, ito yung susunod na tanong. What if magkaiba po sila ng exponent? What if magkaiba ng exponent? Let's say, anong number kaya pwede? 7.31, ito pa rin, plus 1.1 times 10 raised to 2. Ito, magkaiba na sila ng exponent. Ano na gagawin mo? Kasi ang kailangan kapag addition, subtraction, same exponent. Kaso ito, hindi eh. Yung isa 10, yung isa 3, yung isa 2. Pagpaparehasin mo sila. Ano meaning ko doon? Di ba remember, when you move your decimal point to the left, ang exponent, nagpa-plus 1. Move mo 2 steps to the left, plus 2 na yan. So, plus 2 na to. Diba? If I move my decimal point to the right, minus 1 sa exponent yon. Another movement to the right will make it minus 2. Okay? So, in order for me to have, for them to have the same exponent, may uurong akong decimal point. Okay? Para ma-adjust yung exponent. Again, keep in mind, pag to the right, positive. Pag to the left, positive yung exponent. Pag to the right, negative na. So, ano gusto nyo? Ako gusto ko 3. Gusto ko parehas 3 yung exponent nila. So, pag parehas 3, wala na akong gagawin dito. Retain ko na yan. Pero ito, babaguhin ko to. Babaguhin ko to. So, paano? Kopyahin ko ulit, ha? Ayan. So, gusto ko yung exponent niya maging 3. And sabi ko nga kanina, pag to the left, plus 1 sa exponent. Ibig sabihin, iurong ko lang to. Papunta sa left. So, dito na yung magiging decimal point. Then, since isang urong to the left yan, plus 1 yung exponent ko. Okay? Magpa-plus 1 yung aking exponent. So, that means, itong number na to, I can write that as 0.11. Oopsie. So, I can write that number as 0.11 times 10 raised to 3. Pwede ba yun? Yes, pwede. Kapag nag-ooperation ka, okay lang. Kahit hindi siya 1 to 9 yung integer. Okay, so pwede yan. Pwede mag-adjust. So again, ano ginawa ko? Itong 1.1 times 10 raised to 2, ginawa ko 0.11 times 10 raised to 3. Bakit? Para parehas sila ng exponent. Okay? Kasi pag parehas sila ng exponent, doon ko lang sila pwede i-add. So I made the exponent the same by moving the decimal point to the left. So every time you move to the left, plus 1 sa exponent. If you have questions, sige, ask lang kayo. I will proceed with the addition. So now I have the same exponent times 10 raised to 3. So since parehas na sila ng exponent, I can add the integers na. 7.3 plus 0.11. Okay, pwede ko na i-add yung integers. So this will become 7.42 times 10 raised to 3. And that is my final answer. Okay. So again, kapag magkaiba ng exponent, gagawa ka ng paraan. No? You have to adjust it so that magiging same yung exponent nila. Okay. Then pag na-adjust mo na, yun na yung sagot mo. Okay. Pag may question, don't hesitate to ask ka. Siguro tatanong nyo, sir, try nyo nga kapag 10 raised to 2. Sige, gagawin ko yan. Kahit wala naman nagtanong. Gagawin ko naman 10 raised to 2. Okay, dito ako sa kabila. No? Itong 7.31, gagawin ko siyang 10 raised to 2. Paano? Every time you move to the left, plus 1. Every time you move your decimal point to the right, minus 1 sa exponent. So ito, yung 3 gusto ko maging 2. Paurong ko to the right. So magma-minus 1 ako dun. So this becomes 73.1 times 10 raised to 2. And then I can add it dito sa aking number original. Okay. So plus 1.1 times 10 raised to 2. So i-add ko na lang yan. So 74.2. Sorry. Ito pala yan. 74.2 times 10 raised to 2. Copyhin mo lang yung exponent. However, itong answer mo na to, that is not yet the final answer because the final answer should be the proper form, no? So kailangan itong integer, kailangan pasok siya sa 1 to 9. So iuurong mo uli yan. Urong ka uli ng decimal point, then mag plus 1 ka dun. So you will still end up with the same answer regardless kung ano yung sinundan mong exponent. Okay? So same ha. Sa left, ginawa kong times 10 raised to 3 dito, times 10 raised to 2. But because I have to comply sa rules ng scientific notation, ang ending, parehas lang sila. Okay? So that's the addition and subtraction. For the last part of our session today, multiplication division naman tayo. Yung multiplication division mas madali. Okay. By the way, kapag nag-subtract ka, same rules pa rin ha. Hindi ko na ipapakita yung subtraction. Okay. Ayan. Last one, we have to multiply and divide. No? Ang rules kapag multiplication division, medyo nasasanay na ako sa tablet. Dati kasi gamit ko iPad, no? So mabilis malobat na eh. Tagal na nun sa akin eh. So nagta-tablet na ako. Okay. So kapag multiplication division, ang rule lang dito is multiply, divide the integers. Parang kanina lang din, add, subtract the integers. No? Yung exponent, hindi na kailangan parehas sila. Okay. Hindi na tayo mahigpit sa exponent. Kasi kapag multiply, ang ginagawa natin, add yung exponent. Kapag divide, subtract exponent. Okay? So, ibig sabihin, hindi na kailangan parehas yung exponent. Kailangan lang i-add mo sila at i-subtract. Okay? So, to give you some example, since madali lang to, dalawa lang bibigay ko muna. Let's have 5.3 times 10 raised to 2 times gawin ko tong 3. Okay? So, 5.3 times 10 raised to 2 times 3.1 times 10 raised to 3. So, again, multiplication yan. So, i-add ko yung exponent. Add ko sila. So, 2 to, 3 yun. So, ano yun? 2 plus 3. Okay? So, basically 5. And then, I also multiply my integers. 5.3 times 3.1. Ayun, so ito yung ginagawa ko ha. Multiply, divide the integers. Depende kung anong operation. So this times that. Ito yun. And then yung aking exponent, since this is multiplication, I add them. 2 plus 3. Okay? So ano sagot? So this will be 2 plus 3, 5. Ito naman, 5.3, 3.1, Cannot be. Kakalkyo ko. Hindi na kaya. Ang aking utak ay natutulog pa rin. 3.1. Okay, so that's 16.43. Oopsie. Okay, so that's the answer. Yet, hindi pa yan tapos kasi again, I have to express the correct way of writing scientific notation. So, urong mo uli yan until you get 1.643 times 10 raised to 6. Bakit siya naging 6? Kasi I move the decimal point to the left, and again, every time you move it to the left, plus 1 doon. So that's our answer. Okay. So that's how you multiply. Pag may question or may clarification, sabihin nyo na ha. Okay. So for now, I think wala pa, no? So medyo clear naman sana, no? Kapag multiplication, multiply mo lahat ng integer as yung exponent, i-add mo lang. Kapag division, gawin natin. Okay. So kapag division, palitan ko yan. Ayan, divide na siya. Basically, i-divide ko to. Then yung exponent, isusubtract ko. Okay? So, yun lang yung magbabago. So, pag division, divide the integers, 5.3 divided by 3.1. And then yung exponent, I subtract them, 2 minus 3. Okay? This minus that. Divide ko lang to, 5.3, 3.1. Ang daming number. Susulat ko na lang yung first 4 digits. And the first 3 digits na lang. Ayan. 1.71 times 10 raised to 2 minus 3. Negative 1. So that's the final answer. 1.71 times 10 raised to negative 1. Okay. Yun na yan. So, ayan. So basically, we're done with this. With the operation involving scientific notation. Siguro there will be times, no, baka magtaka kayo. Sir, pwede ba to? 3 times 10 raised to 0. Pwede. Okay. So, pwede yan. So, 0, ibig sabihin, hindi mo ginalaw decimal point mo. Okay. Pero pag ginalaw mo yan, magkaka-number yung exponent, no? So again, plus 1 pag to the left, minus 1 pag to the right. Okay? Kapag may question, don't hesitate to ask me, but that's it, no? So that's how we do operations involving scientific notations. So sa Thursday, mag-discuss tayo ng significant figure and then yung conversion. Mabilis ang conversion lang. Okay. So every Thursday pala maaga ko kayong i-dismiss. Ideally, i-dismiss ko kayo around maybe around 12:30 na. Okay. So 12:30 or earlier. I-dismiss ko kayo kapag Thursday. And so ganun lang ha. Hopefully may natutunan, no? Sana may natutunan today. So again, to summarize everything we discussed today, ito yung mga pinagagawa natin. We take a look, no, into how we represent measurements. So basically, measurement is composed of 2 parts: the number or the magnitude and the quantity, no. So the quantity or the unit makes sense of the number. So 2 carabaos, iba yun sa 2 kilograms, okay? So yan. The unit makes sense kung ano yung number na yun, okay? And then we also check the history of the measurements. So we started with the English or the imperial system, followed by the metric, and later on the international system of units. So ano lang yung mga improvement dito? Kapag English system, ang nangyari is body size ang form of measurement. However, that is found to be unfair, especially for traders, no? Kasi magkakaiba yung size ng katawan ng tao, no? So kapag ikaw nagte-trade ka sa kabilang kaharian, lugi ka. Okay? So nagrevolusyon sila uh, remove the English system and to convert it into the metric system. Okay? So sa metric system, this is a product of the French Revolution. So instead of using body sizes, they instead used physical objects. No, nagset sila ng standards, and also they introduced the decimal system, making the conversion much easier. Kasi kagaya ng ginagawa natin sa sa scientific notation, nagmo-move lang tayo ng decimal point. No? Ibig sabihin, if you are converting units in the metric system, you're just moving decimal points. Okay? And these are the units established in the metric system. And it also introduced the prefixes. No? Itong prefixes, ito yung product ng decimal system. No? So you add this prefix if you want to multiply your base units. No? Kunwari, you have 1,000 grams, you now call it 1 kilogram. Okay? Ibig sabihin nun, 1,000 siya ng base unit. No? If you have 1 million kilogram, 1 million grams, no, ng isang object, you can now call it megagrams. No? Yung iba, medyo weird pakinggan, no? Pero yun. Megagram. No? And yun, ang problem is until now, may gumagamit pa rin ng English system. So we have to do conversions na. Magagamit natin to sa session natin sa sa Thursday. Okay, and then the SI unit, ito naman, instead of using physical objects, we instead used we instead use universal constants. No? Ayan. Okay, so ayan, I emphasized on this one, the weight and the mass. Sabi natin, yung mass, yun yung actual quantity ng matter. Ang weight, yun ay yung mass mo times the gravitational pull. So, ibig sabihin nun, yung nasa resume natin or nasa biodata, pag sinulat yung weight, mali yun talaga, no? However, the consideration lang naman is that we still we live on the same planet, no? Wherein the gravitation constant is very identical, no, in different places, no. Medyo similar yung gravitational pull sa mundo naman. Okay? So yan, pwede na natin i-disregard yung G, no. Pero again, if you're on a different planet, no, it will have a huge change, no. So ito yung time, yung definition natin ng time, no? Fixed na yan talaga, no? Ang pinaka-original roots niyan is yung mga ating astronomers and yung mga nasa dagat na yung mga explorer, no? So sila yung naghati sa skies into 12 regions. Each region is 1 hour ang katumbas, no? So yan, mahilig sila maggamit ng astrolabe and compass. Temperature, so yan, tatlo yan. Fahrenheit, body temperature ang basis. Celsius, water ang basis. Kelvin, atoms ang basis. In science, we use Celsius, no, at sometimes, pero Kelvin ang mas tanggap sa science. And these are the equations to convert. Again, itabi nyo lang yan. Madali lang gamitin yan. So basically, plug in lang yan. Okay? So yan. Density. So ito, dito tayo natagalan kasi nag-exercise tayo. No? Okay? So density, mass per volume. Okay? So and also, do not forget the triangle I showed you earlier. Yung triangle ng wait lang, ayan. Yung triangle kanina. So this is density, mass, volume. Pag naghahanap kayo ng volume, that's mass over density. Pag naghahanap ng density, mass over volume. Pag naghahanap ng mass, density times volume. Ganun lang. Specific gravity, basically, tanggalin mo lang yung units. Okay? I just remove the units na. Saan to ginagamit? Sa medical field. No? Medical field. Okay? And then we discuss scientific notation. This is a way to address yung issue with when it comes to many zeros. No? Okay. So next meeting, to discuss natin significant figures. So pakibasa na in advance. And the operations, turuan ko kayo nito. Okay? And most importantly, yung conversion. So yan. And etong accuracy precision, babasahin lang natin yan. Okay? So with that in mind, so I hope you learned something in your second week of classes here in FEU, and hopefully dumami pa lalo learnings ninyo. If you have any other questions or if you have clarification, do not hesitate to ask me. Kasi 10 lang tayo dito sa classroom, and may group chat tayo sa Facebook, pwede kayo magtanong, no? Basically, treat this as an extension of your family na lang. Para tayong nagsa-cell group dito. Okay? So, yun. So, thank you, and I'll see you again this coming Thursday. And again, I'd like to remind, no, Monday, wala tayong magiging klase niyan because it's holiday. Okay? So, yan. So, I have no more announcement. Do you have any questions? Or okay na rin? I think wala na, no? Okay, so thank you, and I'll see you again next time. Bye-bye, and ingat
Thank you po.
always.
Bye-bye po. Ingat.
Thank you po.
Bye-bye. Thank you po, sir. Bye.